Most of us have probably heard of the idea of brain training, a tool or set of tools, usually on a computer or phone app, that comes with the promise of making us smarter. On the surface, the idea makes sense. If you want to learn to play an instrument, practicing that instrument will almost certainly make you better. The same goes for riding a bike, playing chess, public speaking, and a whole host of other activities. Why shouldn't the same be the case for our intellectual abilities? Unfortunately, so far brain training has failed to live up to its promises. Although there have been many types of brain training developed, and several of them have even shown initial promising results, these results almost inevitably follow a similar pattern. Across time, the initial promises fail to replicate, show reduced effect sizes in follow-up studies, and generally do not live up to the initial hype that they have received. Most of these trainings end up only showing replicable improvements to the specific skills they train. For example, working memory training can improve working memory, but not general cognitive performance. So why have existing brain trainings failed? Imagine for a moment that you are a soccer player who wants to get better at taking penalty kicks. You find that, in general, you score about 50% of your penalties, and 50% of them are misses. That is, you kick the ball inaccurately and it goes wide of the goal. You might try to improve your performance by practicing kicking the ball harder. You go to the gym, work out your leg muscles for hours every day for several weeks. You go back to the soccer pitch and try out your penalty kicks again, but you still get the same result: 50% goals, 50% misses. But how could that be? After all, you practiced, and practice makes you better. So does this mean practice doesn't work? Of course, the answer above is clear. The practice that you did as a soccer player was not targeting the skill you needed to focus on. The problem with your penalty kicks was never your power, it was your accuracy. But when you practiced, you did not practice being accurate. So of course, you wouldn't improve. By analogy, many psychologists argue that the failure of brain training to improve general cognitive performance has been because they have focused on the wrong skills. In other words, the abilities that they train are not at the core of our cognition in general, and consequently they produce improvements only in specific domains. So, what might be the abilities at the core of our cognition? Recently, many psychologists have converged on one particular idea, that relational abilities, namely, our ability to relate different concepts flexibly and in complex ways, are at the core of many of our cognitive abilities. Indeed, whether it be in doing mathematical operations, perspective taking, or engaging in creative thinking, relational thinking is always present. Indeed, relational brain training seems to also improve performances on many of these activities. Particularly in the context of IQ, several studies have now demonstrated that training relational thinking can lead to some strong improvements in cognitive performance. In one landmark study, Dr. Sarah Cassidy and her colleagues found a mean increase in IQ of 23 points in 15 primary school children who completed a relational brain training intervention for several weeks. These increases in IQ through relational training have been replicated in several studies that are listed in the reference list below. Similarly, training relational thinking has also had beneficial effects on children's performances in schools. After several weeks of a relational thinking intervention, children performed better on both maths and verbal tests compared to children in a control condition doing computer programming training. These effects also seem to be quite robust. In recent research currently under review, we and our colleagues demonstrated that relational training improves scores on IQ tests in children even when controlling for their baseline abilities and their baseline attentional skills. Sounds exciting, right? But it's important that we also treat these results carefully. After all, this feels like a familiar story. Many other brain trainings initially found promising results, but then these disappeared after some scrutiny. Indeed, existing studies currently have some weaknesses, including small sample sizes, not always using control conditions, and not abiding by best practices in terms of pre-registration, etc. A recent meta-analysis of these effects in the context of IQ suggested that relational training indeed seems to improve IQ, but that the literature is currently at a strong risk of bias. All of this to say, relational training seems like it could be a better type of brain training, but we need much more rigorous studies to determine this. In our lab, this is our goal. We are currently conducting multiple studies investigating the effectiveness of relational training for children and their educational outcomes, for young adults and their cognitive abilities, for older adults with self-reported cognitive complaints, and for patients who have suffered a traumatic brain injury. Time will tell whether training relational thinking can prove to be a better type of brain training. In any case, it is always important to be sure that the skill we are trying to practice is the skill that matters.